and welcome to this GCSE Computer Science video with me, Mr. Goff, from mrgoff.com. Today's topic is developing algorithms using flowcharts. A flowchart is a diagrammatic representation of an algorithm. They contain only a small number of standard symbols. Those are terminators, input-output boxes, decision boxes, and process boxes. Flowchart terminators are used to mark the start and end of an algorithm. Each algorithm must have a defined starting and ending point. The initial point will be labelled as start, and the end of the algorithm will be labelled as end. The parallelogram-shaped input-output box is used any time the algorithm needs to pause to get input from the user or needs to display something to the user. Decision boxes are used at those points in the algorithm where you may take a different path depending on the result of a Boolean check. A Boolean check is a check of a condition that may result in the possibilities of true or false. As you can see below, is num greater than 10 could result in yes, it is, or no, it is not. A process box is used for a step in the algorithm that is performed by the computer automatically. This includes performing calculations and using string methods, as well as other things. Flowcharts are generally drawn to run down the page from start to end. Arrows show you the direction of the path to follow. With sequence, they'll just go straight down the page. With selection, you might find there's more than one path to take, and with iteration, there'll be a loop created to go back to an earlier part of the algorithm. It's important for the Paper 1 exam to be able to identify the basic constructs in flowcharts. Pretty much all flowcharts show sequence. Anytime there is one box connected directly to another, so they will always happen one after the next, that's an example of sequence. A common misconception of some students is that anytime we see a decision box, it must be selection. However, a decision box will also be present to check the Boolean condition in a form of iteration. The way to tell them apart is that with iteration, there will be a path back up to an earlier part of the algorithm. However, with selection, there will just be different paths towards the end. In this example algorithm, the first steps take place in sequence. We always first get the user input and then calculate the total. The next section is an example of selection. Two decision boxes create three possible paths to the end of the algorithm. This is actually an example of an if, else structure. This algorithm shows an example of count-controlled iteration. The counter number is incremented each time through the loop. Within the loop, there's an example of selection, as we check whether the number is equally divisible by 3 at any given point. An indefinite or condition-controlled loop would have a comparison that was slightly more complex. It would most likely require the user to give new input so that the loop could be exited. That concludes this introduction to developing algorithms using flowcharts. I've been Mr. Goff for mrgoff.com. I hope you'll join me again for more computer science videos in the near future.